any nuclear reactor needs these really heavy radioactive elements, particularly uranium-235, to start and run the nuclear reaction. But why do we have radioactive elements on Earth? Radioactive elements don't last forever, they will break down at some point, so why are they lying around on the Earth for us to mine and use in our nuclear reactors? Also, the vast majority of the radiation on Earth doesn't come from our reactors, it's natural radiation. Why is there so much natural radioactivity on Earth? Now, to understand this, we need to think about where the Earth's elements actually came from originally. And it turns out that a lot of the heavy elements came from thermonuclear supernovae. Now, thermonuclear supernovae are believed to form when you get white dwarf stars. White dwarf stars are the burning the embers left over for a star like our own sun when it comes to the end of their life, and they're generally made of carbon and oxygen. And the normal idea is that two of these things merge, and when they merge, their gravity compresses them enormously and causes the carbon, nitrogen, and oxygen to fuse and produces basically a huge thermonuclear explosion and fire this gas out. And in this nuclear explosion, because the intense gravity has compressed these things so much, all sorts of really heavy and unstable elements can form. And these would fly around in space. Presumably one of these supernovae must have gone off just before our solar system formed 4.6 billion years ago, because some of these radioactive elements produced by this explosion got mixed up with all the other elements when our solar system and our planet and the sun and the moon formed. Now, there would have been a lot of radioactive elements in the Earth back then, 4.6 billion years ago, because of the supernova, but most of them have gone away since then. The only ones that are left are those which have enormously long half-lives, in the sense that, yes, they break down, but it takes them millions or billions of years to do it. So the four main radioactive elements we see on Earth today are uranium-235. This is a half-life of 704 million years, so it takes on average that long for half of them to break down. That's a lot less than the age of the Earth, but there's still a little bit of it left over. Uranium-238 has a half-life about equal to the age of the Earth, so we've got about half of that left over from what we formed with. Then there's potassium-40, half-life of 1.25 billion years. Most is gone, but some remains. And thorium-232, which has a very long half-life, 14 billion years, so we've still got most of the thorium we started off with. And all these radioactive elements have a huge effect on Earth. For example, they're responsible for volcanoes and the fact that the middle of the Earth is hot. When the Earth formed, the middle was certainly very hot because of the collision of all the asteroids that made it, but that would have cooled down billions of years ago were it not for all the uranium and thorium and potassium buried deep down there thousands of kilometers below our feet. And the radioactivity from this has heated up the very well insulated middle of the Earth so that you get lava boiling out. So volcanoes, they're not particularly radioactive, but the heat in them is caused by small amounts of radioactive particles deep in the Earth, slowly decaying and releasing their heat, which is then trapped and can't get out, and so it makes the middle very hot. So that's most of the radioactivity on Earth, but there are other radioactive elements, like you may have heard of radium that used to be used on watch dials to make them glow in the dark, and there are other things, radon gas, carbon-14. Now, most of the things like radium and radon occur from decay chains of uranium and thorium. So if you take uranium-238 with a half-life of 4.5 billion years, it ends up as lead-206, which is stable, but in the process it goes through a whole series of other steps. Some of these only last for example, this step only lasts 1.17 minutes, you don't see very much of that. But some of them, this lasts a few thousand years, 6,000 years for radium, radon and so on, last a while. So for example, the radium and radon gas, those would have been uranium quite recently. The uranium's decayed and produced them. They will last a short time before they decay into something else, and eventually following this entire chain end up as a stable element, lead-206. So that's where we get a lot of radioactive elements on Earth. They're short-lived decay products of one of the long-lived radioactive elements. The other thing we get is that cosmic rays. This is radiation from space, partly from the sun and partly from exploding stars and black holes deep in space. And this hits the upper atmosphere. Most of it doesn't penetrate to the Earth's surface, but in the upper atmosphere it can create nuclear reactions and produce other things. This is, for example, as a source of carbon-14. So that's natural radioactivity.